Hi, I'm Jadid, and I've recently been very interested in style transfer. As I dive deeper and deeper into deep learning, get it? Now, rendering an image in multiple different styles has always been a tough computer science problem, but convolutional neural networks, otherwise known as CNNs, have shown excellent promise in terms of object detection and recognition. Now, before we dig deep into the nitty-gritty details of style transfer, I'd like to tell you that I'll be referencing a research paper by the Computer Vision Foundation quite a bit. Now, links to all the reference material and some other cool stuff can be found in the description below, so definitely check it out. To create these cool-looking images, the computer requires two types of images, a style image and a content image. At a high level, stylistic features are extracted from the style image, and the image content is extracted from the content image. These two features recombine to form the target image, which has the style of the style image, but the content of the content image. Let's begin by taking a look at what happens with the style image. Now, previously, the method of texture transfer was prevalent to perform style transfer. However, determining the textures and colors within the images is not enough. CNNs are deployed in this case to obtain high-level feature representations. This high-level information regarding the texture, basic features, and so forth are extracted from the high-level layers, which fall right after the max pooling layers. Even with these layers, the highest layers are given the greatest weights, as they do not consider global arrangement and more specific and granular feature representations, making them ideal for actually just extracting the style rather than the actual content of the image. Now, even with this set of features, the higher the level, the more priority is given. The content image is dealt in a similar manner, except to extract more of the content feature representations, the lower layers are used. These lower layers focus more on the content and granular representations of the image, which is actually very useful to find out where they are and what it actually represents. However, if the layers are too low, a very slight change in style will actually cause the algorithm to misclassify the image. So we must find a good balance between granular and not too granular. Once these two sets of features are extracted, they recombine to form a target image. Then, in classic machine learning fashion, the algorithm is trained over a number of iterations known as epochs. Originally, the target image will look very much like the content image rather than the stylistic image. However, over variations and various iterations, the computer adds more and more stylistic features to the target image while retaining the content features. The algorithm does this by calculating the individual loss between both the content and stylistic images in the target image. Then these losses are weighted separately to find the total loss, which the computer tries to minimize. When performing this algorithm on a set of images, the results are super fascinating. To try this out yourself, check out the GitHub repo, which contains a code for all this style transfer algorithm, and that is linked in the description below as well. Play around, and who knows, you might end up creating the next famous artwork created by the computer.